All right, ladies and gentlemen, I want to start out by discussing how to write out Newton's second law from a very basic perspective. So we're going to take a very mundane example. We're going to just push a box along a horizontal surface without friction. So here's my box. Here is my applied force. The box has mass m. I'm not worried about numbers. The other forces that act on the object are weight, Fg, which is equal to mass times gravity, and the normal force. The direction of motion of the box is going to be in this direction, so that will be positive. So I will start off by looking at the net force in the x direction, which is equal to max. Now, this object is moving under a constant applied force. There is no friction, so based on those things, I can assume that there will be an acceleration. Now, we are being specific as to which direction we are writing out F net in, and as a result, being specific to which direction we are looking for acceleration. Based on my picture, the only force acting in the x direction is the applied force. And based on my sign convention, the direction that that applied force points in is positive. As a result, when I go to write out F net x, it is a positive applied force, which is equal to mass times acceleration in the x direction. And as a result, acceleration in the x direction is equal to FAP divided by m. Now, this is going to feel like pulling teeth, but I want to also write out F net in the y direction. Now, we are told this box is moving horizontally. It is not moving vertically. Therefore, I know that V is 0. As a result, A is 0. So this V is vertical and this A is vertical. What that means for me is that this term becomes 0. So I begin with F net in the y direction is equal to 0. Based on convention that up is positive and down is negative, normal is positive. Gravity is negative. Net force means to sum the forces in a direction, and in my case it's vertical. So my net force in the y direction becomes F normal, which is positive, minus mg equal to 0. And that gives me for normal force that it is equal to gravity, which is equal to mg. This particular fact is not important here, but if we add friction in, it becomes very important. I hope this basic example was helpful, guys. Thanks, and have a great day.